El título de esta presentación es New Ideas for Old Code y la va a impartir Hamlet Darcy de Canoe, así que os dejo con él. Hamlet, whenever you're ready, you can start.
All right. Can everybody hear me all right? All right. Hola. That's about it. I'm pretty good at a Mexican restaurant as well, but that's... So one thing you need to know before we start is this presentation will be in English, almost entirely. So just be warned. The other thing is, will my clicker work? There we go. Okay, so there's 2 concurrent sessions right now. So the other one is about internationalization with Grails. This session is going to be about some new ideas, some of my ideas for working effectively with legacy code. We're going to talk about some Groovy specific topics. We're going to talk about testing code, Java code with Groovy. We're also going to talk about refactoring Java code just in general without Groovy. So what we're doing today is talking about some Java topics, refactoring legacy code, talking about how Groovy can make this process better. We're going to talk about managing dependencies, dependency management, and we're also going to, for maybe the last 20 minutes, talk about social ideas or team problems and team solutions. So more of a social aspect, how to keep your morale up when you have legacy code or old code. So I'm assuming that most of you do have some old code lying around. And hopefully I can help you with that and get you excited to go and modernize it and fix it. Just before I get into the presentation, these are the things that I do. I don't know if I've met some of you, but I work at Canoe Engineering. We're a Groovy and Grails training and consulting company. So if you have any Groovy and Grails questions, Andres and I can help you with those. There's a man over there named Andres. You'll meet him later. Also, in my spare time, I am a committer on Groovy and CodeNarc. I'll be talking a lot about these 2 technologies at 4:30 today in the AST transformation talk. That one will be very, very technical. So I hope to get people excited for that as well. And otherwise, some of my sponsors are JetBrains, and I have a book in MEEP on Manning. So as the main author Dirk says about Groovy in Action, you don't have to read the book, you just have to buy it. It's enough. So that's his joke, not mine. And it'll be the funniest thing I say all day. So I'm only going to ask you to raise your hands once. How many people have old code or legacy code? Yes. Yes. Who thinks they had the biggest class file? Talking about lines of code. Who has the biggest class in the room? Andres, how many lines?
I think it's 13,000.
Oh, that beats me. 13,000 lines of code. And Andres, do you have that beat? My biggest was 10 at our last job. And I shrunk it down over maybe about a year to about 10,000 lines of code, not 10 lines. 10,000 lines of code. And over about a year and a half, I shrunk it down to 7,000 lines. And this was victory. You know, we had really simplified this system. And that was adding new enhancements as well. But the point I want to make is that almost everybody in the room raised their hand when I asked, do you have legacy code? But if I asked you for a definition of what legacy code is, I think we'd get about 70 different definitions. Some people might say it's not stable, it's not testable. Is it tested or not? Some people define legacy code as code without tests. Or some people even go further and say it's code that I wrote more than a week ago because I don't understand it anymore. Is this enough to define legacy code? Is legacy code simply code without tests? You know what? I don't think that that's a perfect definition of legacy code, but the 2 are correlated enough. You find so little tests with legacy code that typically you can say if it doesn't have tests, it's almost certainly legacy code. But it's not important to define what legacy code is because everybody knows they have it. And if I ask you, we'll talk about metrics later, and you can have tools like Sonar that give you code quality metrics. But if I asked each of you, where's the problem area in your code base? You probably know the problem area. You probably don't need empirical help finding that problem area. You know where it is. The problem is you either don't know how to fix it or you're scared to try to improve it. So in general, what I recommend for trying to address these legacy code issues or solving them is set a plan and know where you want to go. The problem with not setting a plan is that you may go in a lot of different directions. You may have 3 different teams solving a problem in 3 different ways. And that creates more complexity, and as complexity grows, you get more and more legacy code. So this session is about trying to set your priorities and trying to pick a direction of where to go. And this session is also about learning how to get there. Some new tools, some new techniques for trying to execute whatever your plan is. And one piece, the last piece I want to mention, is the 51% rule. And this is something I created. It's not a physics rule. It may not hold up to mathematical analysis. But when I talk about the 51% rule, I mean that if you're not doing the right thing 51% of the time, your problem's getting worse. If you know you want to write more unit tests and have better test coverage, and you're writing unit tests on 25% of your code, at the end of the year, you're going to have a lower coverage. If your goal is 50% coverage, you're going to have lower coverage than what you started with. If you know that, I see this with development teams and QA teams, if you know that regression testing is a manual process and you want to automate that, you want to get a test automation tool in, and you have a 4-person quality assurance team, and you decide to hire 1 person to do automated regression testing, well, there's 4 people working on manual test cases and 1 working on automated test cases. At the end of the year, you're going to have a bigger problem than you started with because there's 4 people working very hard to create the problem, manual test cases, and only 1 trying to fix the solution. So if you know what you want to do and you're not doing it over half the time, you're going to make the problem worse. At the end of the year, you're going to have more problems. You're digging a hole, and you're not stopping digging when you see that you've gone too deep. So let's talk about, let's show some code. I think every presentation of mine has some code. So let's get to code. Does anybody know the difference between refactoring and re-engineering? I've made the definitions up myself, so you'll probably guess wrong if you want to throw out a guess. So refactoring to me has a very specific definition. And refactoring versus re-engineering is the difference between cover and pray. When you want to make a change to your system, write tests out, write some coverage, and then modify the system under test. Edit and pray is the opposite, where you just make some changes, and then you see if it works, you push it to production and see which users complain. So this is a good way to find out how many users you have, by the way. It's based on how many complaints you get. So refactoring has a very specific definition. Martin Fowler, as far as I know, coined the word. He wrote a book called Refactoring, so I guess he's the king of refactoring. He says in the introduction of the book, he says, whenever I do refactoring, the first step is always the same. I build a solid set of tests for that section of code. And refactoring really captured my imagination and gave me a lot of energy because it was a step-by-step process. It was a bunch of recipes that I could follow. And the first step was always write out unit tests. And if you're not writing out unit tests first, I claim that you're not really refactoring. You may be doing re-engineering, but we should be specific about the words we use. I work in a lot of big enterprises, big companies, and we do a lot of refactoring, but we don't always have a lot of unit tests. What we're really doing is re-engineering. Why it's important for me to make this distinction is because eventually, if you're making changes without tests, you will introduce a defect. You will introduce a defect into production. And me personally, I'll get called in front of management meetings or meetings and say, well, where did the defect come from? Why did it get into the system? And if the answer is we were doing refactoring, the response from management or your managers is going to be, well, stop refactoring. But if you had no unit tests to begin with, you weren't really refactoring, and you were just changing shit. And if you go into that meeting with a production defect, and they said, where did the defect come from? And you said, well, we changed some shit without unit tests, it's going to be a very different conversation. They're going to say, why don't we have unit tests? And that's a conversation I want to have. I want to have a conversation. I want to set out a plan about how to add more tests into a code base. I don't want to have a conversation about should we be doing refactoring. We should, but we should be doing it correctly. With legacy code, there's a big dilemma. You're not supposed to change code without tests. With legacy code, you can't write tests without changing the code. So where does that leave us? If you haven't read Working Effectively with Legacy Code by Michael Feathers, it's a great book. I highly suggest it. He understands this dilemma, and he suggests that if you can't at least have tests before refactoring, then at least do pair programming before re-engineering. It's a way to get a second set of eyes on the problem and a way to validate that what you're doing is correct. But there's other things you can do as well to refactor without test coverage. One is to lean on the tools. Tools like your IDE, tools like FindBugs, tools like CodeNarc. So FindBugs and CodeNarc are static analysis tools for Groovy and Java, respectively. And what they do is they analyze your source code and they look for common problems. And if you have, they look for defects, they look for style issues, they look for, Java idioms that are obsolete. If there's a new method that came out in Groovy 1.8, what CodeNarc will often see is that you're using the old way of doing something, 1.7, and it will prompt you to update your code so that it looks more modern. So if you're leaning on the tools and having static analysis or automated tools help you make your code more modern and help it look consistent, then that'll help you have a clear picture of what classes do and what their responsibilities are. But why I like leaning on the tools, especially automated tools, is that they do offer some degree of safety. For Java tooling, it's a very good degree of safety. If you rename a method, it's probably going to be done right by your IDE. If you extract a method in Eclipse or IDEA or NetBeans, it's going to be done correctly. With Groovy, it's done most of the time correctly. There's certainly some bugs in the tools. It's a dynamic language, so it's harder to make these types of program transformations. But it's still possible, and especially IntelliJ IDEA has a lot of refactoring tools, even for Groovy code. And the last one is, when you don't have tests, is to lean on the compiler. Understand what the compiler does for you, what it enforces, and lean on that. For instance, we all use rename for local variables or rename for fields, and it's an automated refactoring in our IDE. But honestly, we don't really need it. If you rename a local variable, the Java-C compiler is going to complain about that. And this, I think, is one of the good points about Guillaume's talk with the static type checking, is that Groovy is going to get this soon. And I think it is a big win when you can start leaning on the compiler and knowing that there's a whole class of errors you could make that the compiler will enforce if you do it correctly. And then you're free to make those errors because you have basically a partner. You have the compiler running and telling you if you did that correctly. So let's look at a few safe refactorings for Java that you can do without unit tests. You don't need BPM. Now, I have an opinion about business process modeling. What I mean here is big procedural methods. After the break, you can hear me talk about BPM, but I'm on video right now, so I can't give my true thoughts. So big procedural methods. This is not a big procedural method, but it does fit nicely on a slide. It's a trade-off. But if this were a big procedural method, for instance, save, the problem with this method is that it's doing a lot of different things. It's running some validation, it's performing a partial save, it's running some more validation, and it's finishing the save. And this may be 100 lines long in your class. There may be try-catch blocks everywhere. There may be exceptions being thrown. Using exceptions for flow control is a common legacy problem, where you throw an exception locally and catch it 10 lines below. It reminds me of go-to statements in a way, which everybody agrees is bad, yet not as many people agree that the flow control is bad. But what do you do with these really big procedural methods where it just says do this, do this, do this, and do this? And one of the safe refactorings you can do with IDEs is extract a method object. Take the whole thing and extract it out into a new method. Make that method static. Keep extracting parameters out of the method until the thing's static, and then move it to its separate class. And what this refactoring does for you is it allows you to put down test coverage on the enclosing class, because you can now mock out this saver object. Now, you can't really test the saver object because it still has all that big procedural code in it, but you have removed the dependency on all that code, and you can now mock it out. So that's one way to test the enclosing class when you have a big procedural method, is get it out of there and move it somewhere else. A different refactoring you could do Remember I said in the beginning, know where you want to go. These are two different ways to refactor the code, and what you want to do depends on your context. But a different way is to break out each of the areas of functionality into its own class. So if you had basically a big procedural method that was 4 steps in a procedure, you could break each step out into its own class, and this would allow you to easily put down test coverage on each of the steps. So depending on what you want, if you want to put down test coverage on the enclosing class, you may want to break out a method object. If you want to put down test coverage on bits and pieces of the big procedural method, then you may want to break out into several different classes. And what I like about this second example is that it fits into a composite pattern fairly well. You can start decomposing your procedures into a set of steps and eventually actually abstract that out so that all save methods would be the same. Even if it is a procedural save method in concept, and the implementation is all the same, and you have the actual logic somewhere else that can be tested. So is a query validator 1 or a partial saver a meaningful abstraction? An abstraction is supposed to take you away from the problem so that you don't have to worry about the details. Is this a meaningful abstraction? The alternative is a meaningless abstraction, something that exists only so that you can mock it out, or only so that you can put test coverage down. And the problem with a lot of these refactorings is that the attributes that support good testability also make for poor readability. If you have one concept in your system, a user service, in Java especially, not so much in Groovy, you end up often with 4 domain objects, 4 objects to model one concept in your system. You may have a user service, and you may have a user service impl, and then you have a user service test and a mock user service. And there's a lot of accidental complexity here to trying to get test coverage down on your code. So that's something to be aware of. And that's, again, back to the guiding principle of knowing where you want to go. Think about where you do want to go with these methods and these big methods and these objects, and then talk about it with your team and decide for yourselves what the balance is between a meaningful abstraction and testable, easy-to-use code. So one of the things we did in my past work was use Groovy for testing. I was excited about Groovy. I am excited about Groovy. It's not past tense. And I wanted to get it into my company, but it's a big, several thousand person company. It's very hard to make changes in the big enterprise. And they were against the idea of just using Groovy, just throwing the jar into the class path of all of our servers, and just away we go. So what I proposed, and we did this, was on a new project, we started using Groovy for testing, just for test cases. And at that time, there was no Spock. It was just Groovy test case and the base Groovy abstractions that came with Groovy 1.0 or whatever version it was. And the concern from the group was, I was saying that testability with Groovy is easy. This is an easy path to get higher testability. And the opposing team, this was a competition by all means, the opposing architect said, no, Groovy is a notational convenience. Anything you can do in Groovy, you can also do in Java. Sure, you can also do it in assembler. I challenge anyone to write all their unit tests in assembler and then tell me where you work, because I will definitely not apply for a job there. But this was the two concerns. One group was saying testability with Groovy is easy, and the other was saying it's a notational convenience. It's not going to buy us enough value for the complexity it introduces. So what we did was we took one project, our team, 5 or 6 people, and we said for this project we're going to commit to 90% testability, and we're going to commit to using Groovy for unit tests. And we did that for about 9 months. And it was the most fun I've had at that job the whole time. I found that some of the contractors that we had on the team, they were brand new to the group. They'd never seen Groovy before. And so the Groovy they started writing at first was very Java-y. Everything had a semicolon. There were no closures anywhere, manually declaring lists. And over about 3 months, they got to a very Groovy style of writing unit tests. What we found was we didn't spend less time writing tests. We spent the same amount of time writing Groovy tests as we spent writing Java tests. But the test coverage was much, much higher. There was actually probably, overall, there was more code written in the test tree, but it was so easy to test error conditions. It was so much easier to test edge cases because it was easier to mock things out that we ended up writing more tests, having better coverage, and overall having better quality. So in one sense, it was a big win for us. We wrote less legacy code on that project than we had in the past. In the other sense, it was a failure because the company eventually decided not to use Groovy. They said after 9 months, we decided as a group that we took a vote in a sense, and then the lead architect decided, after he cast aside the vote, he said that we're going to not use Groovy. And for good reasons. I'll explain it in a minute. So there were some big successes. By and large, everybody that had written Groovy unit tests liked it and wanted to continue. And people who hadn't were still afraid of it. And I think that was a failure on our part to really manage, and not manage people, but to educate people and to let people know what we were doing and involve everybody else. So why was Groovy so successful? I think it's because Groovy is a low ceremony language. There's less complexity and less accidental syntax than Java. In my idea, it's sort of a DSL for testing. In this case, it was. For instance, if you want to assert that there's some values to rewrite this in Groovy without list literals or without closures, it's harder because there's just so much more code and so much more complexity to writing simple tests. Another thing you do in test cases that you do not do in production code is make tons and tons of objects. In test cases, you make an object in every state you can imagine it in, at least around the edge cases, and then throw it at your system under test so that it can be tested. So if you're testing a login window, you might make it without any parameters. You might make the login window with just a username. You might make it with a username and password, and then you might test it in all those scenarios to make sure that there's no invalid state, that it's not going to fail for some state. And to write 3 overloaded methods in Java, you're talking 20 lines of code. And to do it in Groovy, you're talking 1 method definition with default parameters. So I really like using default parameters in the test tree because so much of the code I write in test cases is about making objects, making them in different states. And especially with default parameters, Groovy makes it really easy to create these objects and make, basically, you're making overloaded methods. The class file down below does have an overloaded method on it, but there's just so much less ceremony on it. It's much easier to do. And if something's easier to do, you end up doing it more often. So I stand by my comment that testability with Groovy is just easier. You get the same amount done with less work. Another thing that we really benefited from was the XML support in Groovy. We were doing, at the time, it was an Access2 web service container. And Access2 has its own API for creating XML, and it's horrible. This whole block of code, all it does is create a root XML element and attach 2 children below it. And if you've ever implemented a Groovy builder, you know that with dynamic typing, you can make this much easier. We implemented a Groovy builder for this, and this was the result. We're saying there's a root element. It's just like a markup builder it's just like markup builder or the other builders you're used to working with, except that it wrapped Access2 components. So you're dynamically creating a root element and then creating 2 children, and attaching some attributes to them. So if you've never written a builder before, I highly encourage you to do it. I thought that there was a little bit of a learning curve. You definitely had to try it out and understand how it worked. There's at one point there was an abstract builder support that you could descend from. You could subclass and get it done. But it took us a little while to write the builder and feel comfortable with writing a builder. But once we did, the value was really huge because I challenge anyone to look at this code and tell me what the parent-child hierarchy is of that XML block. Whereas you look at this code and it's very, very clear. So the test case, yeah, it's less lines of code, but it's also more expressive. It communicates what the data structure looks like. And it communicates that physically. There's a root element. These things are indented and they are children. It mirrors very nicely what you see. And to the people on the other side that were saying, it's just a notational convenience, you can build XML out of strings. And if you look at this string, that does also communicate what the structure is of the XML. Now there's a whole bunch of string concatenation. It's not very easy to push strings into that representation. Sample 1 and sample 2 are hard-coded. But there is some truth that with the right Java API, some of this can be eliminated. Now we were doing a lot of XML web services, and I thought when I left the project that was sort of the end of XML web services for me. And now I have 2 different projects right now that are doing XML web services. I can't get out. I try to get out and they pull me back. That's not a Godfather impression. So, well, maybe it was. It's just bad. So one of the things we really liked when dealing with XML was, geez, you know what? I made a mistake here. This should be a multi-line string, in fact. If you want to mirror an object hierarchy, this was an example with one of our tests. We'd create domain models and then make sure they were serialized to the right XML that we wanted. We were doing some testing around our serialization stuff. And you can see, no, I'm sorry, this is good. You can see in the Java version, you're doing string concatenation, you're trying to add variables in, and it makes it very difficult to read, even if there is a string form available. And what we liked about Groovy was just even a simple feature like multi-line strings and string interpolation. So it's a multi-line G string. You can still have this nice XML block. It's not an XML literal, it is just a string, but you can easily substitute variables into the string. This is just G strings and multi-line strings. But we got so much value out of it compared to having all this accidental complexity within Java. So it's these small features that combine to make Groovy kind of a DSL for testing. One feature that we used occasionally was private method access. So there is a open Jira ticket for Groovy saying that you can access private methods. And it's marked to be fixed in Groovy 2.0. Is it a feature? Is it a bug? I'm not sure. Some people think accessing private members, private methods, some people think that's insanely useful. At times it is. And other people would say that it's insanely evil, that you really shouldn't access private members. So, there's this, for me, of course, context is everything. And there's a time to access private members and a time not to access private members. And to me, it comes down to when you're dealing with what type of input and output you're dealing with. The book XUnit Patterns had a very clear definition of of input and output. There can be direct input or indirect input, and direct output or indirect output. The simplest thing to test has direct input and direct output. You pass a parameter to an object, and it gives you back a result. Everything in Java util math has direct input and direct output. They're static methods with no side effects. So these things are very, very easy to test. Every string utilities method you've ever written has direct input. The response is based purely on the input. You give it a parameter, you get a result. For indirect input, you are passing an object that knows how to locate something. So maybe you're mocking out an object, and you're mocking out a getter. You pass that object to your method, the getter gets called under the scenes, and somehow you've mocked it out. And that's indirect input. And of course, indirect output is anytime you have to test a void method, anytime you have to test a side effect. So if you have direct input and direct output, if you have a simple method and you're using private method access to get at that method, that's probably bad. It's such a simple thing to test that there's better alternatives. Recompose the class so that it's reachable, so that it's findable, not private. Recompose the API of the class so that you can test the direct output, so you're not reaching in and looking at private fields. So up here, if you're not using private method access, well, that's the best thing. That's a perfect world. And what's not so bad is if you're trying to provide indirect input to a third party. If there's code that you don't control and you're trying to provide values to it, and you're accessing a third party's private fields, well, that third party library is probably written in Java. And at that point, you don't have a lot of options besides accessing private members. And at that point, it can be very, very useful. This is the area where it becomes a very useful feature. At the other end, if you have your own objects and every method you write returns void, And every method you write takes a long parameter list, and there's all these getters, and you're trying to have to mock out a lot of things. And the only way to test it is with private method access. I would say that's code that you control. So in a sense, you're free to change it. And so it'd be much, if you control the code, then it's much better to just restructure the class and not use private method access. Especially in production code. If you're using this feature in the test tree, well, if there's a mistake or a refactor in the production code, then you'll get a test failure. I mean, it is executed every time. But if it's in production code, it's a very bad thing to do. So just be careful with private method access. If it's code you control and you can change, then don't use it. And if it's not code you control, then it can be very useful. Some of the downsides we experienced with using Groovy in the test tree, some lost benefits of test-driven development. What I like about test-driven development is that it validates the API for you. When you write an API in an object or a service, you have a user that's using that object. It's the test. And if the API is difficult to use, you know that you should refactor the API. So if your production code is written in Java and your tests are written in Groovy, there's some things that you should watch out for. For instance, Groovy does not require you to catch checked exceptions. So if you have a service method in Java that has a throws clause that throws 10 different checked exception types, that API looks totally fine when you're consuming it from Groovy. And as soon as you write a Java client against that API, it's horrible because you have to catch all these different exceptions. So that's one way that's one thing you have to watch out for. Also, Groovy has list literals, and it has map literals, and it has closures, so it supports functional programming very easily. It's easy to write a method that takes a closure in a list and does something, iterates over that list, or you can have very list-based and map-based APIs and make it very easy to consume from Groovy. And as soon as you try to consume that same API from Java, the client code has to create new hash maps and populate them, and create new array lists and populate them, and it's more of a pain. So if you're doing this, be careful of your exception types, and be careful of list and map types on your APIs. There might be better APIs to write. 2 years ago, when I first started thinking about this topic, this was when the project was, the IDE support was questionable. I think that the Eclipse support, even in the last year, has come along very well. I think I'm very positive about how Eclipse and Groovy are going forward. And the IntelliJ IDEA support is very, very good. You get a lot of refactorings. You get a lot of code analysis. But at the end of the day, if you're used to searching for a reference and having your IDE find all of the reference usages, and your reference is something like get ID, that's a very common method name. And with a dynamically typed system, it's very hard to determine what the false positives are for finding something called get ID. Create a map that is really an implementation of an interface, where you have the key is ID and the value is a closure. And that is a get ID method. So yeah, I don't think the IDE support will ever be as good as Java. And if you have people that need an IDE and love their IDE, then this is an uphill battle. That this is a concern. This is a concern you're going to have to address when you're lobbying to try to use Groovy. Lastly, is this a language decision? Is it a language decision to put Groovy into your company, to put it in the test tree? It is a new language. The Groovy advocates, me included, will tell you that Groovy is very easy to learn for a Java programmer. You can write plain old Java code, and mostly it works the same. But in reality, it is a new language. And as people get better with the language, the code will start to look less and less like normal Java. And if you take 5 Java programmers and then give them Groovy, the first couple months it's going to look like Java code. And then they're going to discover the power of closures and writing methods that take closures as parameters or return closures as results, functional composition. And it's going to stop looking like Java and become something very, very different. So on some basis, it is a language decision. And it's not enough to tell people that it's easy to learn, and because you're Java programmers, you'll learn very quickly. Those things are both true, but in a big company, I do think it is a language decision. At the end of the day, it's a serious decision to make. One recommendation I make when introducing Groovy into a company, especially when you're mixing Java and Groovy, is to make sure that you have a one-way dependency. Groovy should depend on your Java classes, but to start, I would recommend against having Java depend on your Groovy classes. If they're in a separate module and you're putting dependencies together with something like Spring, then that's probably okay. But it is possible to have a Groovy interface with a Java subclass, with a Groovy subclass of that. But it really tightly couples your decision to use Groovy. It makes it harder to back out that decision. So overall, when there's one big project and you're mixing Java and Groovy within the same project, within the same component, I recommend having a one-way dependency. To start, have Groovy depend on Java. It's simple. It's the safest thing. And then as you get more comfortable, you'll have more information to make a better decision later. Do you really want two-way dependencies? How should you structure your modules now that there's a new language? At the end of the day with this company, the problem, we were thwarted with our Groovy adoption. I really pushed for Groovy hard. A couple other people did as well. And at the end of this 9-month project, we decided not to go forward with it anymore. And the problem was that there was one huge monolithic code base with 40 or 50 developers working on it. And when you have that, it wasn't composed into modules. It wasn't composed into components. And when you have that situation, you have 40 or 50 people working on the same code, sometimes working on the same class files at once. And it's chaotic. And your biggest problem in that scenario is your module system and your modularization. It's not, getting your unit test done. Well, one of your biggest problems is the modularization. And until we fixed that problem, it wasn't a good idea for this company to continue using Groovy. The problem, to put it bluntly, was the teams that were writing Groovy, when something broke or when a unit test failed, anybody who didn't like that decision or hadn't been involved in the original decision would just come to us and say, it's your mess, you fix it. And I'm a positive guy. I can do that for so long. But at the end, if some people in your team aren't committed to trying something new and are going to put up roadblocks to it, it's going to be very hard to get that adoption. And unless you can fix that personal issue or fix that team issue, it's going to be hard to adopt anything. And that was the problem with one huge monolithic code base. We had our team, but there's no such thing as a local decision. Every decision we made affected everybody, 40 or 50 developers. And so in a sense, the team was 40 or 50 developers. And we hadn't realized that, and we were trying to push through Groovy in this case, and we hadn't gotten everybody on board. Of course, they didn't throw it out completely. The tests still run, and most of them still pass, I suspect. And we found other ways to introduce Groovy. We introduced Grails in the QA department for mock services. We introduced Groovy in our messaging layer because of the XML support. It was very easy to parse messages and route messages around. So overall, it wasn't a complete failure by any means, but it was an interesting time. So managing dependencies, I'll talk briefly about managing your dependencies and having modular software. I get excited about dependencies. I'm passionate. I'm not going to jump around and scream like a monkey. I did that at one conference and everyone just looked at me. So I will not scream like a sweating beast, but I want to. Inside I'm just screaming dependencies. So at a very micro level, what are the dependencies? What's the coupling? How cohesive is this class? This class has 5 methods: create, wheel, drive, build body. How cohesive is this class? Which methods depend on which other methods? Which methods depend on which fields? There's no way to tell, right? It's impossible. And on a very micro level, one of the small refactorings I always make is private methods for me are almost always static. Almost always static. And the reason for that is that when you have a static method, its dependencies must be on the parameter list. And once your private methods are static, you can read down the API, the private API of a class, and you can very easily see what the dependencies are. Build has a dependency on wheel, pedal, and body. Body, pedal, and wheel don't have any dependencies at all. And it's much easier to see what your dependencies are. You're not looking at fields. You're not looking at the implementation of private methods to determine how coupled or how cohesive things are. You're just looking at the structure view or the hierarchy view of a class. So one of the small things I always recommend, especially in legacy code, is to strive to make all your private methods static, because they declare their dependencies, and it's much easier to see when there's a new class. When you have a 13,000 line long class, there's certainly some classes in there that are waiting to come out, to be extracted. There's certainly some methods that are tightly coupled together and should be pushed off into another class. And if everything's private and static, it's easy to see that. Static methods declare their dependencies, and instance methods, they hide their dependencies. You can't tell. I'm not recommending public static methods, although in Groovy is not such a problem, but in Java it certainly is. On a broader scale, inversion of control, this is dependency injection. This is the idea behind dependency injection. If you have an object, don't go out and find what you need, but have other people tell you what you need. A concrete example is if you have a long constructor that creates a database connection that goes and does a query, goes and finds a couple other services, looks up some services from the JNDI registry, that's service location. You have a really, really long constructor, and it's almost always impossible to mock out. And with inversion of control, you take all those dependencies and pass them as parameters to the constructor. So pass what an object needs. Don't go and locate it in your constructors. There are, of course, dependency injection frameworks. Spring is the one I'm most familiar with. That's the one I always use, so I'm sort of qualified to talk about it. But when you're taking legacy code and trying to convert it over to IOC or dependency injection, the first thing I do is introduce constructor parameters, get those dependencies out of busy constructors, get them out of there, introduce parameters. If you're introducing constructor parameters in an object and you find that your constructor has 8 or 9 parameters and there's too many of them, if any method or constructor has 8 or 9 parameters, you probably missed one. If there's 8 or 9 there, the problem isn't that there's too many parameters, it's that there's too many dependencies. You need to refactor the class to make things smaller, to decouple things, not stop showing your dependencies, because you're just managing your dependencies differently. So with legacy code, introduce constructor parameters until there's a small subtree of things that have IOC, and then sort of snip that entire tree with an application context or with a juice injection unit or whatever it is. So strive to find some small part of your dependency tree that you're going to say from here down we're using dependency injection, we're going to fix it and use something better. Start elevating constructor parameters out. And at the point in your application where that you're creating all these objects and manually setting up the dependencies, that's where you can introduce an application context. So I've used this successfully on legacy code projects and found several places where you can sort of snip these dependencies. And at the end, we eventually merged those application contexts and had something much more manageable. So dependency injection is a big help. What time am I ending? Abraham? I have 10. 15, okay. So, so one of the things I highly recommend doing, I've talked about working effectively with legacy code already. Some other really good books are Refactoring to Patterns and Clean Code. So at our company, we did book studies on these groups as a way to get people excited and a way to get people knowledgeable about some of these problems and solutions. And in general, I would say a book study on something like the refactoring book. If nobody's familiar with refactoring, yes, start with that. But a book study on something like Refactoring to Patterns, it worked very well. The chapters are, reasonably short, and it's easy to cover it in a group. Clean Code is a great book to do a book study on. Well, let me rephrase that. It's a great book to read. Is it a great book to do a book study? If you're going to do a book study on Clean Code, meet once a week and review chapters, read the book first and set a schedule about what you're going to read. There's some controversial advice in there. There's some good advice and there's some bad advice. And I would say if you're a leader on your team, try to pick out the good advice and suggest using that. Because the problem is the bad advice how you should name variables, how methods should be ordered in a class, white space. Everybody has an opinion on white space, and it doesn't do anybody any good to have a 30-minute discussion about it. And just make a decision and do it. So you might want to moderate clean code if you're doing a book study. And the last one is working effectively with legacy code. It's probably not a good book to do a book study on. If you're going to try to use this, I would say try to create more of a course. Read it yourself, pick a couple chapters to read, and then read specific chapters. The problem is it's a really long book. It's almost 400 pages. And so to get 5 or 6 people on a team excited about any 400 pages in the world is pretty hard. Whereas the other ones are shorter, easier to digest, easier to read. So I want to end with talking about some social problems with legacy code, with legacy teams. I categorize these into you problems and we problems. Not that you have a problem, but a you problem is something that it's within your power to fix, that you personally can do something to fix. And a we problem is something that the whole team has to fix. It's a little bit harder. You can't just go to work on Monday and say, hey, I'm going to fix this problem. Well, one of the problems is being burned out and depressed. I've said this to myself, not in the last couple months, maybe. I've said this to myself. Eric Nagum, who passed away a few years ago, said, God grant me the serenity to accept the code I cannot change, the courage to change the code, and the wisdom to know the difference. So don't try to fix everything. If you try to fix everything in a 13,000 line long class, that's your full-time job for 6 to 9 months. Just a ballpark estimate. You'll get burned out and depressed. Figure out what do you want to fix? Where do you want to go? What are the changes you want to make? Here's another one. I've never said this since joining Canoe. My coworker, I continue to say, I'm an idiot. Why did I do that? But I've never said my coworkers are idiots. But I've had this thought before, and I want to ensure everybody, from a medical point of view, I think it was the American Psychology Association, an idiot is someone with a 0 to 25 IQ, and they need help breathing. They need machine assistance to breathe. Your coworkers are not idiots. They might be morons. You can get by in society pretty reasonably at 70. So this is an obsolete chart. This was used in the early 1900s. So this isn't how we classify idiots and morons anymore. And for good reason. This is not a helpful medical definition by any means. But the problem is not intelligence. It's broken reward structures, often. It's broken reward structures. Different people are motivated and rewarded for different behavior. And a lot of times the strongest conflicts in my history have come when I'm rewarded by certain things. I'm rewarded by engineering excellence, by quality, by a job well done. Those are things I get really excited about. And if someone tells me they have a project and they want it to have a lot of quality and make the right decisions, I'm excited. Other people are rewarded by really nice usability, really nice user interfaces. And that's a very different concern. And if you have two people with very different reward systems, and people in your company are, people got to your company and got promoted and got hired because they're good at something. And so to respect that, I think it's better to try to understand how people are, what their incentives are, why they're doing the behavior they're doing, and not just think that they're dumb. They probably just have a different opinion or a different reward, and try to understand why they're doing what they're doing, and not just call them an idiot. Because again, denigrating people isn't going to help solve the problem. I hate my job. Some days, depending on how much sleep I have, this is really the correlation. If you hate your job, the number one advice I have is do something uselessly cool outside of work. You can tell when my project's a boring project because I'm more active in mailing lists. I'm more active with CodeNarc. There's a lot more going on in open source. When my projects are exciting and I love my job, I don't really do any of that. It's an outlet. It's an outlet for when I'm not feeling rewarded. I found a huge open source community that you can be a part of. So if you really don't like it, do something uselessly cool outside of work, and you never know what it might turn into. It might turn into a better job. It might turn into a better team. It might turn into ideas for making your team better. One way, so find a way to make it fun. So I'm a bit of a silly person at heart. I ran a contest once to promote testability. Pirates used to be cool. Then it was ninjas, and now it's zombies. I'm still stuck on pirates. I'm really hopeless like that. One thing I did was I created a contest at work, and whoever checked in the 1,000th unit test got a prize. I didn't tell them it was a handmade bookmark of our architect. It's really a crummy prize, but it was the best I could do with zero budget. Another thing I did was the 100% club. This was a club, and if you got 100% unit coverage on any class, you got to be part of the 100% club. And you got your picture taken with a Polaroid. I still have a Polaroid. And after there were 8 people, management threw us a pizza party. Well, they bought us lunch. I'm not 8 anymore, so it's not really a pizza party. Management bought us lunch, and we sat around and talked about how we can get more testability. We very easily figured out who are the people that care across all the teams. And then we got together. And we continued this for a couple iterations, getting people excited. And I'm not recommending 100% test coverage, but if you've never written 100% in your life, how do you know that 80% is the right midpoint? How do you know that's the right point that's a balance between too much and too little? How do you know that 40% is the right balance? And everybody has a target of what they think is an acceptable unit test coverage. And if you've never, ever in your life gone beyond that target, how do you know it's not too low? That's how I live my life. If you've never drunk too much, how do you know when to stop? So I was talking about my teenage years earlier. I spent a lot of time finding this balance when I was younger. The lights are a little bit too bright here, but finding ways to introduce new technology into your workplace, yet do it in a risk-free way. That's something that you can do. For instance, here's a retrospective from one of our teams at Canoe. Things that they wanted to keep doing was EasyB. EasyB is a test framework. It's not production code. You can do whatever you want to a unit test, and it's really not going to break once it hits production because it doesn't go to production. You might even end up finding more defects if you're introducing new technology in the test tree. So the test tree is a great place to experiment. You see JRebel down here. JRebel is a deployment tool, but it's modern, it's exciting. You can invest in it and have really no risk of breaking things in production. Gradle, web test, Spock, Jeb or Geb, I do it wrong every time, Sonar. These are tools that you can use outside of production code. These are technologies you can put into your project and not have a big sign-off period because it's not going to production, and have lower risk of breaking something in production. I can't do it alone. No, you can't. You can't do it alone. It requires a large commitment, especially if you have a lot of legacy code. Back to this 51% rule I mentioned earlier. If you're not doing the right thing more often than not, if you continue to do the wrong thing the majority of the time, after a year, your problem will be worse. So beware of cross-team dependencies and try to find allies. We don't know how to do this. Book clubs, those book clubs I mentioned, speaker lunch and learns, share a Canoe. So these are two things that we do at Canoe quite a bit. If you know that there's a Groovy conference coming to Madrid, email some of the speakers beforehand and say, why don't you come and give a 1-hour presentation at our company? Get people excited about a technology. I know, I'll speak for us, Andres and I are happy to do that sort of thing. I know a lot of other people are, and I've had quite a few speakers show up at my workplace to give talks just because you email them and say, hey, you're in town, can you swing by for an hour? And this is what we'd like to do. So having a big rewrite brings a lot of problems. I stand by change is either incremental or excremental. I'll stand by that. I'd rather staff for 51% change. I'd rather staff with the right people, get the right people on the team, and let us iteratively improve the product. I'd rather do that. There's a great set of blog posts called The Big Rewrite by Chad Fowler. And he really, it's 6 parts. He really captures the problem with these big rewrites really well. Where to start? Test-driven development for defects is always a good place. Code coverage minimums, I'm not a big fan of code coverage minimums because you spend a lot of time talking about how much coverage should we have, and you don't spend a lot of time talking about how do we get more coverage. And it's more important for me to learn new testing techniques to get people excited about testability rather than to devise metrics about where we should get. We can make a statement about where we want to go, but if we don't know how to get there, we'll cast aside those metrics very quickly. And of course, you can switch to a new team or a new company, and there's nothing shameful about that. So I don't know where to start. I said, everybody sort of nodded earlier when I said most people know intuitively where they should start, where their big problems areas are. And tools like Sonar, Code Metrics, they can help you. I think that, for me, I like to start where there's unstable code. And it used to be that unstable meant the code crashed a lot. But to me now, unstable code means code that changes all the time. Look at your version control history and see which file has a revision number of 500 or 600, a file that's changing with every single check-in, versus a file that has a revision number of 2. Don't spend your time refactoring and improving code that never changes. Spend your time refactoring and improving the code that changes a lot. And the one last thing before heading to Q&A is try to avoid tumbleweeding. A tumbleweed in the American West is this giant weed that sort of blows across the desert. And this is one of my biggest problems in development is tumbleweeding. I like to blow across code bases and fix small problems, fix typos, rename things because it's easy to rename. Get all the code warnings out of a code base. But what are you really doing? Think about what is the biggest problem you need to solve, then focus your effort on that. Don't just blow across a code base fixing these small broken windows when you see them. Fix it when it's convenient, but focus on what the plan is, what you need to do, and focus on the important things, not the small things. And death by 1,000 clever ideas, I've seen in one code base once, I saw 3 different implementations of a generic object factory, which was a very, very minimal reimplementation of Spring. You'd give it a class and it would give you back an instance as a way to apply a little indirection so that you could mock things out easier. There are 3 different implementations, and then there's also 2 or 3 open source frameworks that you could use to all do the same things. The problem is the teams weren't communicating with each other. They weren't talking about what it is we need and how we're going to fix a problem. And this is important to just having a plan, deciding what it is, and then sticking to that rather than having everybody come up with their own plan. So those are some new ideas for legacy code. There's some things I certainly cannot help you with. Database compatibility. Data lives forever, and databases are sometimes the hardest things to change. Team members you can't get rid of. If there's somebody on your team you have no power, and they're really obstructing things, and you have no power to get rid of them, that's a problem that I've never been able to solve. And specifically, your problem at work. Everything has a context, and some things work in some contexts, and other things don't work. So this is all maybe very specific advice, but without a context, without thinking about it yourself and saying, what of this is going to be useful and what isn't worth my time? That's what we need to do over the next couple days, and return to work Monday excited about making some positive change, excited about putting Groovy in the test tree, excited about these new technologies. So the last hazards are fear and resignation. Fear that you're going to break something, or resignation to the fact that your legacy code will always be this way and there's nothing you can do to fix it. So just get over it and buck up. So these are my contact details. Certainly, if you have any questions, we can ask them now. Like I said in the beginning, I do work for Canoe Engineering. It's a for-profit company, so feel free to call, and we can help Groovy and Girls training, as well as things like this, coaching and refactoring coaching and things. So, but other than that, there's ways to keep in touch, and I'll be around all day. So questions and answers. Oh, I promise that questions can be asked. I can't promise that answers will be given. So questions, maybe answers.
You have skipped a slide talking about we have no time. Can you explain a little bit about this problem?
Yeah, so there was a slide that said we have no time. And I would say there's things to do that are very, very quick to do. One of my examples is, very quick code reviews. Just as you're checking something in, give it a code review. And that can take up, a minute, 2 minutes? I mean, if you're really, really rushed for time. But at least other people can share the knowledge. So something like fast code reviews, requiring that a check-in be done as a pair check-ins, not pair programming. I mean, it's not ideal, but you can always find a few minutes to do something positive. Not that that's going to improve overall. After the year is over, you might be worse off than you started, but you're trying at least. So it's hard. It's hard to find time. But even starting with something simple like that, it gives you energy. And a lot of these things are about giving people energy and making people aware that our job is to make positive change, not just implement some feature as fast as we can. And even when you stop to take 2 minutes for every check-in and do a quick code review, that communicates to your team that you're committed to doing whatever small thing there is, and that can be a stepping stone onto something bigger. So it's not the end point by any means, but at least start. That's what resignation. Don't be resigned that this has to be the way it always is.
¿Alguna pregunta más?
So at 4:30 is Groovy Code Transfer. At 4:30 I'm giving a session. I don't know the title. It could be Groovy AST Transformations. It could be Groovy Code Generation. But it's going to be about AST transformations and code generation, and it should be really technical and really fun. So I definitely would love it to see as many people as possible there. So spread the word.
Thank you very much, Hamlet.
Thank you.